All right, more establishing identities, you guys. I know some of these can be frustrating, but more practice will make you better at it. This question is actually one from your homework from yesterday. It's number 17, so if you didn't get that in your homework, here it is. Some hints, you've got some squares in your equation, so that's a hint that you're probably going to need to use identities. Kind of weird that you have a fourth power in there. If you look at your identities here, there's nothing with a fourth power in there, so you're going to need to kind of think about some other tricks that you have, okay? So, first of all, what I'm going to do on the left side is I am going to factor a secant squared out of there. So I can factor a secant squared out, and then I will have secant squared minus 1. Okay, let's see if that did me any good. So secant squared minus 1, secant squared minus 1 right here is tangent squared. So secant squared minus 1 can be replaced with tangent squared. Secant squared minus 1 can be replaced with tangent squared. And then if I use those same things, secant squared right here can be replaced with tangent squared plus 1. So secant squared can be replaced with tangent squared plus 1. Okay? And now if I redistribute this through the parentheses, tangent squared times tangent squared is tangent to the fourth. And tangent squared times 1 is tangent squared. And I have just turned the left side into the right, which was my goal. Again, notice I don't have anything circled. My work is my answer. All right, here's your next one. I'm noticing that on the left I have secant and tangent. On the right I have sines and cosines. So I'm thinking a good strategy here would be to change everything to sines and cosines. Okay? So if I use my trig proportions, secant can be rewritten as 1 over cosine. And tangent could be rewritten as 1 over cotangent, but that's probably not going to do me any good since I have sines and cosines on the right. But I can change it to sine over cosine. Okay? So secant can be changed to 1 over cosine, and tangent can be changed to sine over cosine. Okay, luckily I have common denominators, and so I can put that quantity together and make it look like this, 1 minus sine over cosine. Now I want you to look at where you are right here and where you need to be when you end up. And what you should notice is that they're flipped, they're reciprocals of each other, but I also have a change in signs. So this is negative right here, and this is positive right here. And when that happens, when they're flipped, when they're reciprocals, with a change in signs like that, it is a clue that you need to use what are called conjugates. And I know it's been a while since you've done this, but you're going to use conjugates. Like the conjugate to x plus 5 is x minus 5, okay? So you're going to use conjugates, and in this case you're going to use the conjugate to 1 minus sine, which is 1 plus sine. Okay? And if I multiply the top by that quantity, I also have to multiply the bottom by that quantity, because then 1 plus sine over 1 plus sine is like multiplying by 1, which is legal. Okay? On the top now, you are going to need to FOIL that out. So 1 times 1 we know is 1. 1 times sine is sine. Negative sine times 1 is negative sine. And negative sine times sine is negative sine squared. Okay. Then on the denominator, I'm actually going to not distribute that out. I'm going to leave it like this. And that's usually what you're going to do in your denominators, is to not multiply it out and leave it. And that's what I'm going to do in this case too. All right, then what happens is your sine and your negative sign will drop. And so I will have this on top. And people will get tempted to cancel the ones and one of the sine squareds with a sine. But again, you have to think of those as entire entities, since they're separated by addition and subtraction signs, and you can't cross just part of that entity out. That's not going to work. So you need another strategy. Now, I still have some squares in my equation, which is nice. And when I have 1 minus sine squared right here, that can be replaced with cosine squared. When you have identities in your equation, or in your expression there, you're often, or squares in your equation, sorry, you're often going to have to use identities. You usually will use identities or factor, one or the other. Anyways, 1 minus sine squared, this quantity right here, can be replaced with cosine squared. I'm going to do it down here so that we have it neater. Okay, and now what I can do is I can cross this cosine out with one of the cosines, because cosine squared is really cosine times cosine. So I can, and I'll write that so that you can see this. And then one of those will cross with one of those, and then you'll have cosine at the top and 1 plus sine at the bottom, which is exactly where you need to be. So I have just turned the left side into the right side of our equation there. All right, a couple more. Again, I'm looking at the left side and thinking, oh, I have cosine squareds in there. I have to have a cosine squared on the right side, so that's good. This, to me, is my oddball. This sine squared does not fit in. I would be singing that Sesame Street song. Okay? So, I am going to replace sine squared with something. Now, I could replace it if I wanted to. I could use my trig proportions, and I could see how sine is 1 over cosecant. So sine squared is 1 over cosecant squared, just so you know. And you might need to use that in your homework. In this case, it's not going to be helpful for you, but you can do that, okay? I, though, am going to replace sine squared and use its identity. And sine squared can be replaced with 1 minus cosine squared. So I'm going to replace sine squared with 1 minus cosine squared. And then I have 4 cosine squared here. And then I will distribute this 3 through. And then all I have to do is combine my like terms and I'm there. If I have negative 3 cosine squareds plus 4 cosine squareds, I have 1 cosine squared. And then of course you have this 3 right here. And again, I've just turned the left into the right, so hopefully that wasn't too bad for you. All right, and another one here. You've got to do this one, okay? I've got cosine squared on the top, and that's kind of an oddball to me. And I could replace cosine squared with 1 over secant squared. Probably not going to do me much good here since I have sines. Secant is not going to cancel with sine, so that is not going to do me much good. But I can replace that cosine squared with its identity. And cosine squared can be replaced with 1 minus sine squared. Okay, again, very, very common mistake here is that people will try to cancel a 1 with a 1 and a sine squared with a sine and think that that's legal. But it's not, because you need to think of them as entire entities again, and you can't cancel just part of them. So that is illegal. That is not going to work. You need another strategy. Okay, well, I've got 1 minus sine squared in there, and people have a hard time noticing this, but 1 minus sine squared is actually a perfect square, and 1 minus sine squared can be factored as 1 plus sine and 1 minus sine. Now I have an entity on the top with an entity on the bottom that can be canceled. So I can cancel that and that. And then this is the next biggest mistake that people will make. They'll go like this. And if I do that, 1 minus 1 is 0. And then I have my negative sign left, so I would have negative sign. But notice what you need to have up here is positive sign. Okay, I need to get my right side to positive sign. Here's what people did wrong. You are taking 1 minus this quantity, okay? You have to subtract the quantity. And when you subtract that quantity, you can't just subtract the 1. You have to subtract 1, and you have to subtract negative sign. So you need to think about distributing that negative through so that you have 1 minus 1 plus sign. And then the 1 minus 1 obviously makes 0. And you end up with sine, which is what you need to end up with. So, really common mistakes there. All right, and I believe this is our last one here. I have tangents on the left. I have to get to cotangents on the right. And luckily, if I use my trig proportions, tangent can be rewritten as 1 over cotangent. So I'm going to use that property and rewrite those. Okay, so now I've got fractions within fractions, which is kind of ugly. And you need to remember right now this is 1 over 1. And I need to get common denominators on the top and common denominators on the bottom. So I'm going to change this one right here to cotangent over cotangent. And this one right here to cotangent over cotangent so that I have common denominators. Okay, and then what I will have up top, right here, is I will have cotangent plus 1 on the top, and then my common denominator right here is cotangent. The bottom will be the same except for there's a minus sign in between. Okay, so now I've got my numerator as 1 fraction, my denominator is 1 fraction, and when I get to this point now I can flip it. So instead of dividing by this fraction right here, I'm going to multiply by the reciprocal. Okay, my cotangents cancel, and I have cotangent plus 1 over cotangent minus 1, which is exactly where I needed to be. I've now turned the left side into the right. All right, and this will be your homework when I see you next time.